Hello everyone, welcome all to this physical chemistry practical session. And you can see the aim of the experiment. It is verification of Ostwalds Dilution Law, and this is by making use of an instrument, and that instrument is conductometer. So first I'll explain you the theory and the procedure behind this experiment, and then I'll take you to the lab where actually I will demonstrate this particular experiment. Alright, so here we start. First of all is, what is the statement of Ostwald Dilution Law? Now ODL, which we call it in short, states that the degree of dissociation which we represented in the form of alpha, degree of dissociation alpha of a weak electrolyte is inversely proportional to the square root of concentration. This is the statement, my dear friends. Degree of dissociation of a weak electrolyte is inversely proportional to the square root of concentration. Now my first point is weak electrolyte. What is an electrolyte? Electrolyte, my dear friends, is a substance which produces ions for conductivity. Okay, that is called as what? Electrolyte. जो आयंस प्रोड्यूस करता है कंडक्टिविटी के लिए उसे हम बोलते हैं इलेक्ट्रोलाइट. अब यहां पर हम बोलते हैं वीक इलेक्ट्रोलाइट. तो वीक इलेक्ट्रोलाइट का मतलब क्या होगा कि द वन विच इज गोइंग टू गिव आयंस टू अ स्मॉलर एक्सटेंट. अब डिसोसिएशन के बाद आयंस मिलते हैं जो कंडक्टिविटी के लिए जिम्मेदार है, और यहां पर वीक इलेक्ट्रोलाइट है, तो इसका मतलब ये होता है कि आयंस हमें कम एक्सटेंट पे मिलेंगे, तो डिसोसिएशन विल टेक प्लेस टू अ लेसर एक्सटेंट. ओके, इतना फास्ट नहीं होगा, स्लो होगा. और अगर स्लो होता है दोस्तों, तो याद रखिएगा वो रिवर्सिबल रिएक्शन है. आई बात समझ में? तो वंस अगेन आई रिपीट, वीक इलेक्ट्रोलाइट मींस द वन विच फर्निशेस प्रोड्यूसेस आयंस टू अ लेसर एक्सटेंट फॉर कंडक्टिविटी. Ions are produced by dissociation. So therefore, in a weak electrolyte, the process of dissociation takes place to a lesser extent, takes place at a slower rate, and therefore that reaction is reversible. Alright? ये आपको याद रखना है. Now next thing is, question ये आता है दोस्तों कि ये Ostwald dilution law weak electrolyte के लिए ही क्यों एप्लीकेबल है? Why not for a strong electrolyte? तो मैं आपको इसका एक्सप्रेशन देता हूं. अभी मैंने आपको एक स्टेटमेंट दिया है ये Ostwald dilution law का. अभी उसका एक्सप्रेशन क्या है कि Ka, I am considering it as an acid. You can take it for a base also. लेकिन यहां पर in this particular experiment we are taking into consideration the weak acid. Okay, so dissociation constant of the weak acid, that is Ka, will be equal to alpha square C अपॉन 1 माइनस ऑफ अल्फा. अब देखिए दो रीजंस है दोस्तों जो मैं आपको बताना चाहता हूं कि क्यों वो वीक इलेक्ट्रोलाइट के लिए एप्लीकेबल है. नंबर वन, जैसे मैंने आपको बोला, अगर वीक इलेक्ट्रोलाइट है तो डिसोसिएशन इज स्लो एंड देयरफोर द प्रोसेस इज रिवर्सिबल, एंड देयरफोर वी कैन टेक इनटू कंसीडरेशन द इक्विलिब्रियम कांस्टेंट व्हिच इज द कॉन्सिक्वेंस ऑफ द लीच-एटियस प्रिंसिपल एंड लॉ ऑफ मास एक्शन. Okay, which is applicable to reversible reactions. Okay, that is number one. Then number two is, अब ये देखिए फॉर्मूला देखो, alpha square C upon 1 minus of alpha. Now this alpha when I talk about is all about degree of dissociation. Now when it is going to be a strong electrolyte or a weak electrolyte, the value of alpha is going to change. And how it is going to be changed? And that is, I use it as strong electrolyte and weak electrolyte. So for a strong electrolyte, the value of alpha is approximately equal to 1. It's very close to 1. It's not exactly equal to 1, ऐसा नहीं बोलूंगा मैं, लेकिन it is very close to 1. Okay, that is for a strong electrolyte. Okay, and when we talk for a weak electrolyte, we say alpha value is proceeding towards 0. हमारे पास दो रेंज है दोस्तों, 0 and 1. Okay, अगर exactly 0 है तो वो इलेक्ट्रोलाइट है ही नहीं, because it is not going to produce ions. Dissociation होगा ही नहीं, तो degree of dissociation is 0. So I call those substances as insulator. अगर exactly 0 है तो, लेकिन close to 0 है, 0.1, 0.2, 0.3, then I'll call it as what? A weak electrolyte. तो weak electrolyte का alpha value is close to 0. Strong electrolyte है almost complete dissociation. So alpha का value is very close to 1. Exactly 1 अगर नहीं भी है तो it is very close to 1. 0.8, 0.9, 0.95 and all. तो ये दोस्तों आपको याद रखना है. So strong electrolyte में alpha का value is very close to 1. Weak electrolyte में alpha का value is close to 0. So if I am going to apply this for a strong electrolyte, okay, तो ये alpha का value में substitute करूंगा as 1. 1 minus 1 becomes 0. Anything divided by 0 becomes infinity. तो strong electrolyte के लिए we have Ka value as what? Infinity. तो वो possible नहीं है. Okay? We cannot have an infinite dissociation constant of the acid. आई बात समझ में? तो दोस्तों ये दो reasons है. First is this is the consequence of a Lee-Chatterjee principle and law of mass action, because we are talking about with respect to weak electrolyte and therefore reaction is reversible. और जब रिवर्सिबल रिएक्शन होता है तो वी गेट इक्विलिब्रियम कांस्टेंट. ओके, और दूसरी बात ये है कि स्ट्रॉन्ग इलेक्ट्रोलाइट में ये हम अप्लाई नहीं कर सकते हैं क्योंकि वहां पर अल्फा वैल्यू इज क्लोज टू 1, तो उसका आंसर इंफिनिटी आएगा. ओके, तो आई गेस ये कंसेप्ट क्लियर हो गया कि ओस्वाल्ड डाइल्यूशन लॉ इज एप्लीकेबल टू अ वीक इलेक्ट्रोलाइट. फिर वो वीक एसिड भी हो सकता है, वीक बेस भी हो सकता है. ओके, नाउ इन दिस पर्टिकुलर एक्सपेरिमेंट, in this particular session, we are going to discuss about the acid. Okay, we are not going to discuss about the base, we are going to discuss about the acid. तो यहाँ पर the acid that we are going to consider is going to be acetic acid. तो उसका dissociation reaction कुछ इस तरीके से होगा. CH3COH reversible है, मैंने आपको पहले ही बोला है, is dissociation taking place to a lesser extent, and that is going to give you CH3CO minus and H plus. It's a monobasic acid because it is going to lose only one H plus ion. देखिए दोस्तों, there is a difference between a hydrogen atom and the H plus ion. Acidity के लिए H plus ion is responsible, not the hydrogen atom. Okay, बहुत लोग क्या बोलते हैं, सर यहाँ पे टोटल 4 हाइड्रोजन है तो 4 H plus are released. Okay, and therefore it becomes a tetrabasic acid. No, my dear friends. Only the H which is being attached to oxygen. Okay, वो वाला बॉन्ड टूटेगा and H plus is released because oxygen is more electronegative. ये जो 3 हाइड्रोजन है दोस्तों वो कार्बन के साथ जुड़ा हुआ है, एंड द इलेक्ट्रोनेगेटिविटी ऑफ कार्बन एंड हाइड्रोजन इज ऑलमोस्ट सेम. एग्जैक्टली सेम तो हो नहीं सकता बिकॉज दो अलग अलग एलिमेंट है, इट इज ऑलमोस्ट सेम. और इसलिए अगर कार्बन और हाइड्रोजन का बॉन्ड टूटता भी है तो मुझे हाइड्रोजन एटम मिलेगा, मुझे H plus आयन नहीं मिलेगा. So they are not responsible for acidic behavior. Okay, so only this H which is attached to oxygen is responsible for the acidic behavior, and that is what I have written over here. It is H plus ion. It's a slow reaction, so it's a reversible reaction. Okay, so this is the acetic acid that we are going to taking into consideration in this particular experiment. Okay, next thing is I want to say over here, and that is how to verify this Ostwald dilution law. तो हम क्या करेंगे, we are going to determine the Ka values for various concentrations of acetic acid. ओके, अलग अलग कॉन्सेंट्रेशन ऑफ एसिडिक एसिड का Ka वैल्यूज हम लोग फाइंड आउट करेंगे और फिर हम ये देखेंगे कि द वैल्यू इज रिमेनिंग ऑलमोस्ट कांस्टेंट. Ka values remains almost constant for the various concentrations, and this will verify the Ostwald dilution law. तो इस तरीके से हम वेरिफिकेशन करने वाले. Alright? So for that purpose, we are going to prepare various solutions of corresponding to various concentrations. So here we have to use water. अब दोस्तों याद रखिए, whenever we are using a conductor meter, okay, there are various instrumental experiments, conductor meter, potentiometer, pH meter, and so on. So when we use a conductor meter, please make sure that you are using conductivity water. Okay, what we are using? Conductivity water. Now what is conductivity water? How it is prepared? Okay, redistillation of distilled water, to which some quantity of KMnO4 and KOH is added. अब देखो मैं एक बात बहुत क्लियरली बताना चाहता हूँ कि we say that distilled water is contributing towards ions, which contributes towards conductivity, and that's why we are using conductivity water. But I never mean to say that in conductivity water it will be zero conductance. No, there will be, but then the magnitude of that is very less. Okay, it will be of the order of 10 raised to minus 6, 10 raised to minus 7 Siemens. Okay, ये मैं आपको बताना चाहता हूँ. So please be very careful with this. Distilled water, of course, its contribution towards conductance is very high. Conductivity water is less, not zero. Okay, so this is, my dear friends, the theory with respect to the Ostwald dilution law, which I say first is the definition of Ostwald dilution law, the statement of Ostwald dilution law, then I give you the expression of the Ostwald dilution law. I explained you it is applicable only to the weak electrolyte, and then how we are going to carry out the verification is by preparing various concentrations of acetic acid, and we will show that its values are almost constant. And then I made a mention about conductivity water, redistillation of distilled water, to which small quantities of KMnO4 and KOH is being added. I hope you have understood up to this very well. Alright, my dear friends, now I am going to explain you the procedure of this particular experiment. So, we begin with the part 1, and that is about determination of cell constant. Now we have a conductivity cell that's going to be used. This also, we call it as a platinum cell. So first we need to find out the cell constant. Now cell constant, theoretically speaking, is the distance between the parallel plates to the area of cross section. This is theoretical, my dear friends. So we say its length upon area, and that will be equal to centimeter inverse. If the length is in centimeter, area will be centimeter square, so it will become centimeter inverse. This is theoretical. Practically, how we are going to determine, and that is by making use of KCl. Okay, a standard solution, that is KCl 0.1 normal. So what we do is, in a beaker, which is a very clean beaker, rinse it with some amount of 0.1 normal KCl, and then fill it approximately, say, 50 cm3 of 0.1 normal KCl if this beaker is around 100 cm3. Okay, the filling up, please remember that it should be such that the conductivity cell, the bottom part of that is the parallel plates of the cell, must dip in the solution. Okay, that much you are going to add KCl. Okay, and then it is 0.1 normal KCl. Connected to a conductor meter. Okay, conductor meter. From the conductor meter directly you will be getting the reading. Okay, it's a display readout device. Now whatever the reading you get, that is going to be noted. So note the conductance. And then use the formula. Cell constant is equal to specific conductance of KCl divided by the observed conductance of KCl. Specific conductance of KCl, it is available from the literature corresponding to the particular temperature, okay, because it is dependent on temperature. So that value will be in the numerator substituted over here. Observe conductance, which I said, note the conductance, so that value will come over here. And then you evaluate the cell constant. This is the practical determination of cell constant. Sometimes the cell constant is already provided. Then you need not carry out this step. Okay, you can directly start with the preparation of the solutions. Alright, so once again I repeat, take a clean beaker, rinse it with small amount of 0.1 normal KCl, and then take around 50 cm cube of KCl, provided the beaker is around 100 cm cube. Insert the electrode or the conductivity cell, connect it to the conductometer. The bottom part of the cell must be dipping into the solution, that you have to see. Obviously, when you get taken 50 cm cube, so obviously it is going to dip into it. And then once you connect it to the conductometer, then you note down the reading. Okay, that is the observed conductance. Specific conductance available from the literature, so you can put it down over here, and accordingly you can find out the cell constant. Yes, my dear friends, now we proceed towards the most important part of this procedure of the experiment, and that is preparation of solutions. So we go into the preparation of solutions. Obviously of acetic acid corresponding to various concentrations. This is the most important part, as I mentioned earlier also. If you prepare the solutions very well, then I guess your experiment will have perfect results. So please concentrate on how to prepare this. First point is, always remember, concentration and dilution are inversely proportional. Dilution is many times represented as V. V stands for volume. So concentration and volume are inversely proportional. If I want to concentrate the solution, I need to remove the solvent. Normally we talk about water. So removal of water is concentration, addition of water is dilution. So here in this case, we have 0.1 normal acetic acid. Okay, which I call it as a stock solution, SS. This is given to us. From this solution, you are going to prepare the various concentrations. Okay, by dilution, of course, because the concentrations which you are preparing is going to be less than this 0.1 normal. Okay, you always prepare a solution of a lower concentration from a solution of a higher concentration by means of dilution. ठीक है? तो इस तरीके से कैसे बनाएंगे, कौन से कॉन्सेंट्रेशन बनाने के और किस तरीके से बनाने के हैं, that I will explain it to you. As I already said, the water that we are going to use is conductivity water. So, first point is, we will take 50 cm cube of 0.1 normal acetic acid. I just write down in short AA, and I dilute it to 100 cm cube with CW, means conductivity water, in a standard measuring flask which is of 100 cm cube. Okay, you know what standard measuring flask is all about, and you will see also, okay, in the coming part of this video where I have actually demonstrated this experiment in the laboratory. Okay, so 100 cm cube standard measuring flask, you need to make use of it. 50 cm cube you already prepared out into that, and then up to the mark add water. So what happens is 50 cm cube is diluted to 100 cm cube, so it is 2 times dilution. So according to this, concentration will become half because they are inversely proportional. So therefore this 100 cm cube solution will give me a concentration of 0.1 divided by 2, so that will give me 0.05 normal. Okay, 0.1 का half करेंगे तो क्या मिलेगा हमें 0.05 normal. And transfer it into a beaker. Okay, transfer it to a labeled beaker. नहीं तो कंफ्यूजन हो जाएगा. ओके कि कौन से सोल्यूशन का कौन सा कॉन्सेंट्रेशन है, तो वो कंफ्यूजन अवॉइड करने के लिए आप बीकर को लेबल करके रखो 0.05, so transfer it into that. And we are using the same standard measuring flask. Okay, याद रखिएगा ये, क्योंकि if at all there are some instrumental error, यानी apparatus error, okay, though that error gets nullified. Okay, every time please don't use a new standard measuring flask. Please use the same standard measuring flask. Okay, तो ये एक सोल्यूशन हो गया. उसी तरीके से फिर हमें और दो सोल्यूशन बनाना है. So what we are going to do is, I'll give you a table form so that you understand this very well. Okay, and that is concentration of acetic acid, volume of 0.1 normal acetic acid added, okay, and then the total volume. The concentration of the acid is in normality. Volume we say it is in cm cube. The total volume is cm cube. So as I said, 0.05 normal के लिए हमने कितना डाला था 50 cm cube. Total volume is 100. Okay. फिर next concentration है 0.025. अभी आप 0.1 जो हमारा स्टॉक सोल्यूशन है and 0.025, so you understand it is 1/4. 0.1 को 4 से डिवाइड करो तो आपको मिलेगा 0.025. It is 1/4 of concentration. तो डाइल्यूशन will become 4 times. अब क्योंकि मुझे टोटल वॉल्यूम तो 100 रखना है, तो ये कितना लूंगा मैं 25. So 25 into 4 is 100. समझा आप लोगों को? 50 into 2 gives you 100. So this is 2 times dilution, so concentration becomes half. This is 4 times dilution, so concentration becomes 1/4. और जो तीसरा सोल्यूशन मुझे बनाने का है वो है 0.0125. दिस इज 1/8. इसको डिवाइड बाय 8 करो तो आपको ये मिलेगा. तो 8 टाइम्स डाइल्यूशन. अभी 8 टाइम्स डाइल्यूशन के लिए कितना लेने का हमें 12.5. टोटल वॉल्यूम इज 100 एज आई सेड. तो दोस्तों इस तरीके से आपको सॉल्यूशंस बनाने का है एंड ट्रांसफर इट इनटू द respective labeled beaker using the same standard measuring flask. Please use the same standard measuring flask. Okay, stock solution कौन सा हमारा 0.1 normal acetic acid. So every time, okay, पहले आप 50 ml लो, diluted to 100, तो that is 0.05. फिर next में आप ले 25, diluted to 100, that will be 0.025, और last में आप कितना लोगे 12.5, diluted to 100, so that will give you 0.0125. So this, my dear friends, is the major part of the preparation of the solutions, and then you note the corresponding conductance value. Okay, तो यहाँ पे मैं लिख देता हूँ, note the conductance value of each solution. इसमें आपको 0.1 का भी लेना है, याद रखिएगा. Okay, जो स्टॉक सोल्यूशन है वो भी लेना है और प्लस ये. So that means you are going to take 4 readings. Readings are very simple. Okay, I will always show it to you also in the coming up part of this video. Same video continuation. You can see that. Just introduce the conductivity cell, dip the conductivity cell into the solution, and directly the display is there. And that reading you need to note down. Okay, तो ये है दोस्तों about the preparation of the solution. So please have a look at it very carefully, okay, and try to understand how the solutions are prepared, because if you don't make any mistake in this, the results are always going to be accurate for this particular experiment.